Oh, you caught me. I was rocking out. We're going to talk about a whole different kind of rocks today. Not music, just rocks. So today, our learning target is I can use the rock cycle to describe how any rock can change over time. Now remember, we've been talking about erosion, sediments, deposition, weathering, glaciers, how they shape the earth, water, how it shapes the earth, okay? So other things also shape the earth and over a long period of time, like millions of years, older than Mrs. Tomlinson. So over long periods of times, rock can change. Our key term for today is rock cycle. Say it with me, rock cycle. It's the series of processes in which rock forms, transforms from one form to another. It's destroyed and forms again by geological changes. Oh my gosh, Mrs. Tomlinson, a geological change is like weathering or maybe lava or magma cooling, okay, or sediments cementing and coming together. And that's what I'm talking about with the rock cycle. So eventually you'll come to some kind of diagram that looks like this. It's a lot. You don't have to draw any pictures, just put in some words. This is the rock cycle. There are basically three types of rock. There are sedimentary rocks, metamorphic rocks, and igneous rocks. Well, you can start anywhere. You can see there's lots of arrows. There's an arrow going this way, an arrow going that way, an arrow going this way. So a sedimentary rock, if it melts, it becomes an igneous rock. If a metamorphic rock weathers and erodes, it becomes sediments. And if sediments compact and deposit and get cemented together, they become sedimentary rocks. And if sedimentary rocks weather and erode, they become sediments. And then sediments can become, sediments can become sedimentary rock. They can also end up becoming metamorphic rock. Anywhere you start in this cycle, you can connect one kind of rock to another. It's just a cycle. There's no actual new rock or minerals formed. It just changes form, and this is how it does it with weathering and erosion, melting, heat and pressure, and you're going to learn all about it today in a couple of videos. When you're done, just pick a rock cycle that you're happy with, that you can draw, okay? And then I would like you to write 2 sentences that explain how any type of rock can be changed by the rock cycle into another type of rock. So like sedimentary rock, how can it become igneous? Igneous rock, how can it become sedimentary? A metamorphic rock, how can it become a sedimentary rock? All right, yes, of course you were expecting another notebook page. I couldn't let you down. All right, notebook page 88 today says, I can describe the types of rock found on the surface of the earth. Well, there are, again, 3 basic types of rock, so you'll want to fill these in. Rocks that are formed by layers of sediment buried under layers of more sediments that are cemented together after a long time are classified as this particular kind of rock. Sedimentary. Made out of sediments, sedimentary. There's a clue. Rock that is created by heat and pressure of an existing rock is classified as, and you fill that one in, rock that is formed by the cooling and hardening of magma or lava is classified as, okay, you fill those in. Down here, I would like you to use a diagram or words to describe how fossils are formed. Include the type of rock where sediments can be found. So that's pretty easy also, but I would actually want to make sure that you know that fossils are there, right? Where fossils can be found, okay? Where sediments or fossils can be found. All right, so you have to put 3 types of rock there. So you're going to watch some video, and there are some interactives and me reading to you a little bit today about different kinds of rocks and sediments and how things on the surface of the earth change the way that they've looked since they were created. So let me show you this. Do you like puzzles? Does anybody like puzzles? What was the last puzzle you did? Okay, so some people like puzzles, some people are not puzzle people. But if you're at all a puzzle person and you like to put things together or classify things or sort things, then this might actually be a little exciting to you. The Earth has not always looked as it does now. And you know what? If you look at a map of the Earth and all the continents, they kind of seem to fit together like a puzzle piece. Well, and fit into one big landmass. And there's a theory about this. So, what do you know about puzzles? Look at these puzzle pieces and tell me, what do you think goes together and what might not go together, and how do you know? So some things that you noticed, maybe these two look alike, so they probably go to the same puzzle. Maybe these are the same color of blue, and so they look like they might fit together. But also, maybe not necessarily fit together, but maybe you might notice that these are edge pieces, and you know that puzzles have edges, so these have that straight edge, right? You probably know that out of all these pieces, there are a couple that are different sizes, like this puzzle piece definitely does not go into that puzzle piece. That doesn't fit. That's not a good fit. Well, there's a theory about how the Earth once looked, and there once was a supercontinent called Pangaea. Last notebook page, don't worry, it's the last one for today. The learning target is, I understand there is fossil evidence. Oh my gosh, Mrs. Tomlinson, fossils. We were talking about that a second ago. Yes, we were. Fossils are awesome. I understand there is fossil evidence that supports the theory of plate tectonics. That is our learning target. Oh, I didn't highlight. I definitely need to. Let me highlight plate tectonics and Pangaea. So plate tectonics is the theory that Earth's outer shell is divided into large slabs of rock called plates that move. You're going to watch a couple videos about this. They're really short, like a minute and a half, 2.5 minutes, and they will really help you understand the theory of plate tectonics. This term is Pangaea. Say it with me. Pangaea. It's also spelled Pangaea. That's confusing, so I just picked one of the spellings. Pangaea is a supercontinent that existed when all the continents were joined 200 to 300 million years ago. Have you ever found the state stone of Michigan? Who knows what the state stone of Michigan is? Raise your hand. Yes, it is the Petoskey stone. Do you know what the Petoskey stone is? It's coral. It's coral, ocean coral. What? In Michigan? Well, it's not actually coral. It's fossilized coral. There was rumor and thought that Michigan has not always been where it is. It has not always been in the northern hemisphere even. So you check that out today. See if you can see how Michigan formed or where it might have been in order to be like by a coral reef or have a coral reef around it. Yeah. Right? So about 200 to 300 million years ago, there was a giant continent called Pangaea, and it broke apart, and over, I don't know, a long time, some millions of years, now the Earth looks like what it does. But we're not slowing down. We're not stopping moving. You might have heard of the plate tectonics, right? The plate tectonics. Every continent is moving around. You don't feel it because it's so big, but every continent is moving around and colliding into each other or pulling apart. The Earth is really dynamic. So here's what I want you to do on page 89. There is fossil and rock evidence that support the existence of Pangaea. Choose either the rock evidence or the fossil evidence, or both, and explain how fossils or rock. Explain how scientists use the evidence to support plate tectonic theory. So you're going to tell me which one you believe in or which one scientists believe in that support the theory of plate tectonics. You're going to learn some cool stuff today. Enjoy riding around. Actually, we're kind of surfing on the mantle of the planet right now. Blah, 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 floating around. All right, learn some good information.